Principles of Operating Systems, Chapter 9, Networks and Operating Systems. One of the features of a network operating system is that it'll have an administrative interface that lets the network administrators monitor and maintain the system. The interface is going to have a menu that lets the administrator do things like format hard disks and set up the security protocols for the system. An administrator can also configure security and data backup requirements for the network and for individual computers on the network. Network management can also be used to update software on the computers in the network. Instead of having to visit each individual computer for a manual installation, changes can be made directly over the network. This not only allows for automated software updates and installation, it also helps maintain compliance with software licensing. A system administrator is a person who's responsible for the administration, upkeep, configuration, operation of a computer system. System administrator tries to ensure that the performance and security of the system meets the needs of the users and stays within budget. A multi-user network will typically be maintained by a specially trained network administrator. The network operating system will contain tools for network management, and the administrator has to be trained, has to know how to use the tools. Otherwise, there's not much point in having them. The administrator monitors the performance of the various parts of the network and tries to anticipate problems and take care of them before they have serious impact. To meet the needs of the users, the system administrator can acquire, install, or upgrade the computer components and software, provide routine automation, maintain the security policies, troubleshoot, train and supervise staff, give technical support on projects. The main responsibilities include the installation, configuration, and support for the organization's networks, local area network, wide area network, internet systems, or possibly just a segment of the network system. The on-the-job duties involve oversight of the network systems, control of maintenance of the virtual private networks, VPNs, and routing controls. The tasks that make up most of the administrator's responsibilities would involve adding new host machines to the network, administering network security, administering network services, name services, and email, troubleshooting network problems. Network administrators are responsible for the implementation, management, and troubleshooting of the networks. Their job is to understand the company's needs and to organize their computer system to satisfy those needs. network administrators have to always continually check the data to make sure the system is working and optimized. From the data monitoring, they watch for problems that could be caused by the network itself or by users. And they have to make sure that new users get the proper training in how to use the network. And network administrators have to train their subordinates on how to upload, download material that would affect the network. One of the greatest challenges for managing a network is managing the users. The people who use the network are much less predictable than the network itself. Training, then, is an essential part of any network manager's job, possibly the most difficult part. The administrator must try to make sure that everyone who uses the network understands it and knows how to use it. A thankless task. If the users don't understand the network, they're very likely to do weird things. They don't know what they're not supposed to do. They're going to go ahead and do what they're not supposed to do. One of the prime responsibilities is to make and keep up to date lists summarizing everything that the users need to know about using the network, preferably a single page, highlighting any earlier changes from earlier versions, and distribute these copies to all of the users regularly. Try to make sure that the users read them. Networking operating systems support a number of security features that control access to the network. The features include authorization and permission for access to the network and its resources. They have specific control features such as user management that includes logon controls and passwords. They also provide access control for features like remote access and network monitoring. The goal of security management is to control access to the network resources so that it cannot be damaged intentionally or unintentionally. A security management system monitors the users logging onto the network and to each network resource and refuses access to those who use the wrong access code. A good security management implementation starts with sound security policies and procedures. Authentication is the process of identifying the users. Usually involves a login password dialog, challenge and response, and messaging. It's the way that a user is identified before being allowed access to the system resources. There is a fundamental relationship between authentication and authorization. The more authorization privileges a user receives, the stronger the authentication should be, because the more privileges he has, the more dangerous it can be, and mistake or damage is capable of doing. Accounting capabilities allow for collecting information to be used for billing, auditing, and reporting. They collect information like the user's identities, when they started and stopped working, the commands that they execute. The accounting responsibilities require that the network managers track the services that the users are accessing, as well as the amount of network resources they consume. Corporations, universities, and individuals have developed hundreds of computer operating systems over the years. The best known, most famous operating systems are the ones found on personal computers, Windows, Mac OS, Linux, because most people deal with personal computers. There are some operating systems that are designed for specific kinds of equipment. Apple iOS, Google Android were developed for use on smartphones and tablets. Solaris, HPUX, DGUX, and other variants of Unix were developed to use on servers. DEC VMS was developed for mainframe computers. Apple's tvOS for Apple TV digital media players, Wear OS for Google's smartwatches. There are basically two kinds of network operating systems: peer-to-peer networks and client-server networks. Each of these techniques for connecting multiple devices into a single networked system has its advantages and disadvantages. Client-server networks have greater flexibility. It's easier to add new software, and adding new nodes is a little easier. Peer-to-peer networks are easier to set up and have lower operating costs. When problems come up and the networks need fixing, troubleshooting, and repairing, client-server networks generally have staff to handle the potentially expensive problems. Peer-to-peer networks only have the other nodes tend to be operated by individuals, and the individuals are kind of it's up to them to find the solutions when they occur. The client-server model is a distributed application structure. It divides up the tasks or workloads among the providers of services or resources, called servers, and service resource requesters, called clients. A server host runs one or more server programs that share the server's resources with clients. The client doesn't share resources. It requests resources or service functions from the servers. Clients initiate communication sessions. Servers sit and wait for requests to come to them. Some computer applications that use client-server model, email, network printing, World Wide Web. Some client-server network operating systems, Novell Network, Windows Server, Banyan Vines. Every computer needs an operating system. Networks require their own network operating systems. A server is a computer system that provides services over a network. Services could be things like data storage, file sharing, email management, website hosting, and similar things. Since servers provide services for large numbers of users, it's important that they carry out these functions quickly so that the users don't have to sit and wait. Now, in a relatively simple network, one of the regular computers in the system can be used to run the network operating system, but in larger, more complex networks, the network operating system will reside on a computer server dedicated to that function, providing network services for the network. Services like we mentioned above: file sharing, data storage, email management, website hosting. While in principle, a regular desktop computer can be configured for use as a server. Most servers, though, consist of dedicated machines that are more powerful, faster, and have specialized hardware components. Systems can have multiple servers for multiple functions, and their large systems are often configured together on a rack that makes it easier to keep track of and manage all the hardware, cables, and power supplies. Servers often consume a lot of power, produce a lot of heat, and as a result, they are often put in separate cooled environments. These server rooms have an additional benefit. They give extra physical security. One of the greatest strengths of the client-server system is versatility. Because the system is controlled centrally with a central server, new technology can be integrated into it relatively easily. Of course, when new technology is integrated into the system, staff and users have to be trained to use the technology, and this training can be time-consuming and difficult. And there's going to be a few mistakes as workers learn the newly integrated system and learn to use the system with new protocols. Peer-to-peer networking is a method for delivering computer network services where each of the participants shares part of their resources, permits processing, permits outside access to disk storage, to network bandwidth, to any printers that might be attached. These resources are provided directly to the other participants without having network hosts or services intermediate or facilitating. So peer-to-peer network participants are both providers and consumers of network services, as opposed to client-server computing, where clients are consumers, servers are providers. P2P, peer-to-peer networks, are typically used for connecting nodes using pretty much ad hoc connections. They're useful for lots of purposes, for sharing content files like audio, video, graphic data, anything in a digital format. Real-time data, telephony, for example, is often passed using peer-to-peer technology. Some examples of peer-to-peer operating systems: Apple Share for networking Apple products, Lamtastic for DOS, Microsoft Windows, and OS2 computers. Windows for Workgroup was used for networking peer-to-peer Windows computers. With respect to versatility, compared to client-server, peer-to-peer systems depend pretty much on the existing software platforms installed on individual computers linked to the network. Systems for the entire network can't be changed, but each user can do a significant amount of customization on their individual workstation to optimize for personal use. Of course, in such a system, you cannot assume that all of the users are going to be interested in or capable of installing upgrades. So you can't assume that all of the users have the same or latest version of software.